Hello and welcome to my blog on bicycle crank calibration. So I just want to demonstrate practically some of the difficulties you face when calibrating bicycle cranks when you have converted them essentially into true transducers using strain gauges. So for the example, I've used a left-hand bicycle crank and I've put on strain gauges to measure bending strain and shear strain. So if I just put this aside, I'll just show you where I've situated them with a sketch. So if I use my bicycle crank, there's the tapered end, the pedalled end, I've got a groove at the back, I've got some shear gauges in the centre, and I've situated some bending gauges top and bottom. Now, to calibrate up these gauges or transducer, so that we've got a meaningful measurement, you would normally take a weight and you would measure the output signal, and you would hopefully get a straight line of y equals mx plus c, and that would be the same for, in my case, both my bending gauges and shear gauges. Now, the difficulty that you encounter after your calibration, if you take your crank, is when you apply a load with the pedal, you don't just have bending in the direction that you're pedalling, you've also got a twist in the crank in this direction, and at the top you've also got a lot of compression, and in the bottom position you've also got a lot of tension on the crank, and you can see this when you're calibrating the crank. So if I take my crank here, I'll try and show you again close up, you can see the gauges and the bending and the shear. If I just take my crank again and lock it, I just put it in the power position, lock it in this position, nice and tight, there we go, and I'll attach the calibration bar. So, just a little nip up, and then just run my Arduino board. Now, both these Wheatstone Bridge arrangement of gauges have the same amplification, so there's no difference in how much the signal should be amplified, so any differences are down to the sensitivity of the gauge themselves, or the positioning of the gauges. So I've got, here's a 6 kilogram disc, and here's my pedal as such, and if I put the 6 kilogram disc on, you'll notice there, you get an offset where the blue is the bending gauges and the red is the shear gauges. Now I know from practical experience that the bending gauges are a lot more sensitive, and the other thing I also know is the bending gauges are a lot less sensitive to crosstalk. Now if I move out this disc, you'll see straight away the bending gauge signal has changed slightly, but the red signal has changed, the shear signal has changed by a significant amount. Now the units on the left hand side are unscaled, they're not calibrated, but the point is, you can see the moment in this direction has been maintained, but I've increased the twist, and the bending gauges are a lot less sensitive to that twist. So there's two ways you can deal with that. You either deal with it in the software and account for the offsets you can, and this is why different cranks can return different values. Now, comparing cranks to a gold standard crank, yeah, it's a sensible way to go about it, but the only way to truly know how accurate a crank is, acting as a transducer, is to take it and set it up in a jig and apply known loads. And for example, if I was calibrating this, I would use another calibration bar on the inside of the crank, lock it in position, and take another disc so there wouldn't be any twist acting on it. A less economic solution would be to add a number of gauges on the crank so you could measure all the offsets in all different directions, but the difficulty of that is the power consumption. And on the crank there's limited space, and you can't put a static power supply in the bike because obviously the pedals are going round. So I'll just take that off. So hopefully that gives you a very practical example of why cranks experience offsets and the sensitivity of placing string gauges in a good position, and why you get so many subtleties and different designs of cranks, because they're really trying to minimise the crosstalks and account for any little offsets they have in the software. Anyway, I hope you found the blog useful, and if you have any questions, get in touch.